Hey guys, welcome back to my channel, and today we're going to be talking about derivatives. And in derivatives there's many different things, but we're going to be talking about the simple concepts, and it's just constants, power rule, quotient rule, product rule, and a special one that we'll come to. So first we're going to start with constants. So constants are one of the types of derivatives you're usually going to see. And for example, it's like plus 5, plus 4, that type of thing. So let's say you have 2x plus 4. In 2x plus 4, let's pretend to take out the 2x for now, and let's just concentrate on the plus 4. So plus 4 would be considered a constant. It doesn't have a variable to it, it's just a constant. So now let's say we want to take the derivative of a constant. So to take the derivative of any type of constant, it will always go to 0. That is the main thing. It'll always go to 0. And if you want to help yourself remember that, think of constant, right? Plus 5 also goes to 0. So all of them goes to 0. And think of this way. There's an O in constant. So O, we can represent it as CO, which is basically a 0. So remember, constant goes to 0. All right. Now we're going to go into the next one. So the next one is the power rule. And based on what we've seen before in the power rule, so in the previous problem, for example, the 2x plus 4, right? So in 2x plus 4, 2x would be considered a power, or you'd have to use a power rule for. Plus 4 is just a constant, but 2x. And 2x or 3x squared, all those are different types of powers. And the formula for this is nx to the power of n minus 1. And n is basically just the power, and then after that you're going to subtract the power minus 1 after you take the derivative. So you're bringing the power to the front, then subtracting by 1. So in this problem, let's say with the 2x, right? So we have the 2x. So the 2x, so it has a power of 1. So anything that's empty is power to 1. So let's say we bring that 1 to the front, right? So basically we're doing 1, that's the first part, because we bring the power to the front. So we do 1 times 2, because we leave the coefficient the same, we don't worry about that, x, and then we do 1 minus 1, because according to the power rule, it's 1 minus 1, which is to the power of 0. Now anything to the power of 0 is always 1, so we really don't need that. So finally, we're left with 2. And if you think about it, the way it's written, right, it is written in mx plus b form. And mx plus b basically means m is the slope, x, and then the b. And so slope is also known as the derivative. So if you need help realizing what really means derivative, it's basically just the slope of a function. Okay? Now, let's say we want to do another problem. Let's do a little more harder. 3x squared plus 2x plus 1. Now here, right off the bat, we have 2 powers and 1 constant. So we know that for sure. So that's pretty good. And any constant, as we've learned before, right, is going to go to 0. So that 1 is a constant, so therefore it will just go to 0. We don't need to worry about that. Now we have to focus on the 3x squared and the 2x. 3x squared is a power on its own, and 2x is its own. So you have to do each one separately. When you have addition and subtraction and stuff, you do each one separate. So this, you bring the 2 to the front, which is 2 times 3, which is 6. Then you put x, and then your power is 2, but you have to subtract 1, which makes it 1, but you don't really need the 1 as the x to the power 1. That's unnecessary. So just 6x. And then a 2x, like we talked before, we have a 1, so we bring that 1 to the front. 1 times 2 is 2. And then we have x, and then we have 1 minus 1, basically from the previous problem, which is x to 0, which is 1, so we just leave it like that. So our final answer is just 6x plus 2, because the 1 is constant, so it goes to 0. So that is our final answer for this problem. Okay? Alright, so now we're going to go into the third type of rule, which is the product rule. So product rule is basically when, let's say you have two functions and they're being multiplied, and it asks you to take the derivative of that. Now, you can't really use you can't really use the power rule for that type of situation, so you'd use the product rule. So let's say you're multiplying f of x and g of x. So g of x and f of x are two different functions, and you're multiplying them, and it's asking you to find the derivative of those two. So there's a simple formula for this, and as long as you follow it, you're going to get it right every single time, right? So the formula is f, taking the derivative, and first you're going to keep the first function the same, so f of x stays the same. Then you're going to take the derivative of the second function, so g prime of x. And then product. Product means you're multiplying, which means it's getting bigger and bigger and bigger, right? And one more thing before I forget. That prime basically means taking derivative. When you see that dash here, that's basically a derivative. And d of x is another, or d over d of x is another way to say derivative. And then plus, and then you have f prime of x. F prime means derivative, or the dash, and then g of x. So basically, you're taking the derivative of one, keeping the other the same, then you're taking the derivative of the second and keeping the other one the same is what you're doing. So first one stayed the same, taking the derivative of the second, plus taking the derivative of the first, keeping the second one the second. So it can be either way. You could have done g of x and then f prime of x plus, because you're just adding, so order doesn't really matter. So now we have the problem x squared plus 3 times x to the negative 2 plus 5. Now, this is a product rule because you're multiplying two different functions. You have an f of x function and a g of x function. So first we keep the first one the same, then we take the derivative of the second, and it doesn't matter if it has a negative power, it's still the same process, nx to the n minus 1. So first the power will go to the front, the negative 2 comes to the front, you have an x, and then you would do negative 2 minus 1 from the thing, so it'd be minus 3 as your power. And now that's a constant, so it just goes to 0. Plus, because the product rule, now you have to take the derivative of the first, because you haven't done that previously. So you have 2x here, because it's the power rule, so the 2 goes to the front, the x, and then 2 minus 1 is 1, and the 1 is unnecessary, so you don't really need to keep it there. And then lastly, you keep the second one the same, so it'd be x to the negative 2 plus 5. So now this would be the product rule. So either way, you could have switched that around. I could have put the second part of it first and the first part of it second, and it would still be the same answer because it's addition. Next, we're going to go into the quotient rule. Now, in the quotient rule, you always think of it this way. Quotient rule is used when you have a numerator and denominator. Basically, when you have a fraction, you have a function on the top of the fraction and a function in the denominator. That's when you're going to use the quotient rule, because that's the best way to solve any type of problem using when you have numerators and denominators and stuff. Okay? And there's two different ways to actually write this, but first we're going to go into the actual formula. So we have g x squared on the bottom. So you're taking whatever functions on the bottom or the denominator and squaring that. Then you have to always keep that bottom function. You should never take the derivative of that first, because if you take the derivative of that first, it's going to mess it up. So you do g of x, right? Alright, so now, once we've done the g of x, now we have to multiply it by the prime of f of x, which is basically the derivative of the top function. And then it's quotient rule, so we have to subtract. And then we take the derivative, or g prime of x of the bottom, the lower part, and then we multiply it by f of x, which is basically the top function. And so that was basically the quotient rule in terms of g of x and f of x. Now we're going to do a little cheer. So L stands for low squared, and then LD high minus high D low. And so that is a chant that you can actually remember. So low means low squared, whatever's on the bottom squared. Low, keep the low the same, take the derivative of the high, which is basically the top, minus high, which is the top, the derivative of the low. So that's a little cool thing that you can remember. Alright, so now let's give an example problem. So we have x squared plus 1 over x cubed minus 1. So that's a type of quotient rule problem because it has a numerator and denominator. So the bottom is x cubed minus 1, so we're going to have to square that, the lower part, minus 1 squared, and then the low stays the same if you remember. The bottom is the low and the high is the top, so the bottom stays the same. You don't ever take the derivative of that first, so it would be x cubed minus 1 times the derivative of the top or the high, which is basically just 2x when you use power rule, and then the 1 was a constant, so it goes to 0, minus, because it's a quotient rule, and then x squared plus 1, because the top is now going to stay the same, the high, and then d low, or derivative of the bottom, which is x cubed, 3x squared, using the power rule, because the 3 goes in the front, 3 minus 1 is 2, so it's 3x squared. And so this would be your final answer, and if necessary, you can simplify it if they ask in the problem, but that is your final answer. All right, now we're going to go into that special one I was talking about, e to the x. So, as simple as it can be, actually, the derivative of e to the x power is just e to the x power. And there's actually a formula. Now let's say it was not x, but let's say the power was 2x. Instead of e to the x, it's e to the 2x. Now you can't really, it's not e to the 2x, it's a little bit different. So the formula is e to the x power, so that means whatever the problem is, that stays the same. And then after that, you take the derivative of the power, which is basically here in the situation 2x. So you take the derivative of 2x, which is the power of the e. So first you're going to leave it the same, so e to the 2x, and then times the derivative, or the slope, or whatever, of 2x, which is the power, and that's just 2. And then for safekeeping and to make it more clean, you just write it like 2e to the 2x. And something to remember is that for the first one, it is e to the x, right? And remember that x prime, if I take the derivative of just x, that's 1. So that's why it's just e to the x is equal to e to the x. Alright, so now we're going to just go into all the different formulas we learned today. So first we're going to start with constants. And constant is just adding plus 4, plus 5, plus 6, plus 100, right? And a constant always will go to 0. And remember, O in constant stands for 0, so you can think of O0, O0 whenever you're in doubt. Alright, the next one is the power rule. So the power rule, okay, the simple formula, 3x, 3x squared, 4x to the power of 4x, right? Even x. It's just a slope, right? Derivative is slope, but the formula is nx to the n minus 1. That is the formula for any power rule with the variable of x, or if there's any other variable you may find z, y, use the same form. Use the same rule. Product rule is the next type, and what we talked about is when you have two different functions and you are multiplying them, you would have to use this rule. So it's basically, the rule is you have f of x, which you keep the same, then you multiply it by g prime of x, which is basically just the derivative of another function, and then you add because it's product, and then you do f prime of x because we haven't taken the derivative of that function yet, and then we have g times it by g of x. Remember, you have to take the derivative of each function at least once in the problem, but you can't take the derivative of the same function and add it 2 times. It has to be one derivative, the other still, one still, the other derivative. Now e to the x is just e to the x, which means first you keep it the same as it is, then you multiply it by x prime. And as I talked about, you just e to the x is e to the x unless the power changes, like if it's e to the 2x or e to the 3x. And if it, let's say it had 3ex, the coefficient still stays the same, so it's 3ex. Alright, now finally we're going to go into the quotient rule, and the quotient rule is basically, I'm just going to show you both ways. I'm going to show you the formula, actual formula, and then the chair that you can use to help you in all the problems that you have in terms of quotient rule. So first on the bottom you have g of x squared, and so the bottom is just squared, then you leave it the same. Remember, you never take the derivative of the bottom first. So g of x, then the top, which is f of x, so f prime of x, you take the derivative of that, minus, and then you take the derivative of the bottom now, so g prime of x, times f of x. And so that would be your quotient rule formula. But now we're going to do it in terms of the cheer that we talked about. So it'd be low squared, which is basically the denominator squared, and then low derivative of high minus h d low, which is basically just the low, or the bottom squared. Low stays the same. Remember, you never take the derivative, so derivative of high first minus the high, which stays the same now, and the derivative of the low. And so those are all the different formulas that we have. Thanks for watching. If you have any questions, please put them down below. Any comments or anything you want, any topic you'd like, and thank you.